For ETM 1120, the tenoning fixture is going to be used to cut the drawer front. Instead of doing our setup on the drawer front, I'm going to use the test piece from the lid and base. So I've cut one end square on the radial arm saw, and these two pieces have the same thickness. So whatever I set up on here will be the same as doing it on there. Alright, so I'm going to load my part, my test piece, into the tenoning fixture and tighten it down. Since we're going to make a 1/4 inch cut using a 1/4 inch dado blade, I can set the blade flush with my part as a rough setup. So I'm going to bring my part up. To adjust it left and right, I'm going to loosen this knob here, and that will allow me to make fine-tune adjustments using this knob. Now I can adjust it to where the blade is flush with the top of my test piece, and I can lock it in place. So now with a 1/4 inch blade flush on the outside, it should make a 1/4 inch deep cut. While I'm cutting, to eliminate any mechanical slop, I'm going to pull the fixture this way and push it across. So I'm going to be pulling with the handles this direction, sliding it across the rails. If you push through slowly enough, blowout on the back of the board should not be an issue. As with most things, you want to wait for the saw blade to slow down. If you pull it back while it's still running, you run the risk of damaging your part. So now that I've made my test cut, I can use a pair of calipers to measure the depth of cut using the step on the calipers. It's 0.222, so I need a minor adjustment to get 0.25. This is where using the test piece helps. Otherwise, you would be doing guess and check. You could overshoot the depth of the cut, and you wouldn't really know what you're going to cut on your final part. Again, to measure the depth of cut of my rabbet to ensure it's a 1/4 inch, I'm going to use the calipers. I'm going to use the step on the back of the calipers to measure the distance of that step. And as you can see here, it's right around 0.25. Now that I've done my setup on my test piece, I can cut my drawer front. Blowout on the tenoning fixture is not that big of an issue if you push through slowly. If you're in capstone, you may have a process designed to where that when you make your 1/4 inch cut, you then rip your part down to size to eliminate any blowout. In ETM 1120, since we have a final part on both dimensions, or on both sides, we cannot rip it. We're going to need to use some type of backer board. When you initially get your stock, it's going to be slightly oversized. You're going to rip a thin piece, which will be the exact same thickness as your part. You can use this as your backer board. As you can see with this thin piece, it's extremely flexible and doesn't offer a lot of support. If you find pieces of scrap in the scrap bin to use as backer boards, they must be the same thickness. So this one will not work. It's too thin. So this part is either too thin, and if I flip it up, it's too thick. This will not work as a good backer board. This part here is the proper thickness and will work as a backer board. So the part that was too thick to use for a backer board, if I tried to load it in and then clamp them down, you can see that the clamp is going to clamp on the larger part first and not clamp on this. Or vice versa, if I use a backer board that is too thin, the clamp is going to grab onto the main part and not the backer board. In either case, the backer board will not support the main part and you will still get blowout. So do not use a backer board that is not the right size. Do not step through the motions. If it's not the right board, do not use it. If you do not understand why the board must be the same thickness as your part, ask for help or do not use the backer board. So with a backer board, the same thickness as my part, I can load them into the tenoning fixture, clamp them both down very tightly to ensure they don't move. Since they're both the same thickness, they're both going to be held in place very securely. Now when I make my cut, the backer board will provide a lot of support to prevent blowout on my final part. Again, I'm going to pull back and push through with even pressure at a slow pace. If you do go fast, you will cause blowout. So now that I've finished my cut, in this case I do have a thin wafer. You can press this inward and get a nice crisp edge. If you rip them outward, you run the risk of having splinters pull down your part. In capstone, if you're using this fixture, it's ideal that you either use a wider dado blade so you get the full depth of cut in one pass, or you have a spacer board in the back for your preliminary cut, remove the spacer board and have your final cut, getting your final cut set by the fixture and that spacer board to remove that scrap on the outside. This is showing the large backer board, the one that is slightly too thick. This is 3/4 inch oak versus the 5/8 inch thick drawer front. In this setup, no matter how tight I tighten the clamp, it will not grab the drawer front. It offers no support. Even if the parts are slightly different in thickness, it may have some resistance, but the part needs to be held down very securely. This again shows the drawer front loaded with the backer board now where it's too thin. The backer board is not being held in place, so it will offer no protection against blowout along the main bottom, and it's not thick enough to protect the part that it does need. So again, improper backer board offers no help. With the proper backer board installed, one that is the same thickness as my part, they can be tightened down very securely, and now they will not move independent from each other. So this will provide plenty of support to prevent blowout along the bottom.